Hello, this is Mr. Brooks and welcome to Lesson 8.1, the Pythagorean Theorem and its converse. In this lesson we're going to use the Pythagorean Theorem and the converse of the Pythagorean Theorem. And we're going to try to find the distance between two docks on a lake. Okay, the Pythagorean Theorem. A squared plus b squared equals c squared. In a right triangle, the sum of the square of the length of the legs is equal to the square of the length of the hypotenuse. Again, a squared plus b squared equals c squared. Make sure that you always have c as the hypotenuse, and a and b must be the length of the legs. Next, we need to know what a Pythagorean triple is. A Pythagorean triple is not only when you have a squared plus b squared equaling c squared, but when a, b, and c are all whole numbers, such as 3 squared plus 4 squared equals 5 squared. That's a Pythagorean triple. 5 squared plus 12 squared equals 13 squared. Pythagorean triple. 8, 15, 17, 7, 24, 25, etc. And you also need to know that if 3 squared plus 4 squared plus 5 squared is a Pythagorean triple, then 6 squared plus 8 squared is going to equal 10 squared. See, we took 3, 4, and 5 and multiplied all those by 2. And so any multiples of a Pythagorean triple will also be a Pythagorean triple. So you can multiply 3, 4, and 5 by 3. So 9 squared plus 12 squared is going to equal 15 squared, etc. Example 1 asks us to find the length of the hypotenuse of triangle ABC and then ask if the sides form a Pythagorean triple. So we're going to begin by letting length of AB equals C. So we've got, we know that A squared plus B squared has to equal C squared. And so we're going to say 20 squared plus 21 squared equals C squared. Alright, 20 squared is 400 plus 21 squared, punch that into your calculator, you're going to get 441, and that equals c squared. So 841 equals c squared. Now in this one, we're going to take square root of both sides, and so c equals the square root of 841. We do need to try to find a perfect square that goes in, or we need to try for a perfect square that goes into 841, but on this one I would strongly suggest you just use a calculator and see if that is a perfect square. If you punch that in your calculator, you're going to get that equals 29, so we do have a Pythagorean triple of 20, 21, and 29. Quick check number 1 asks us to find the length of a leg of a right triangle if one leg is 10 and the hypotenuse is 25. So the first thing I'm going to do is draw a picture. That helps me a lot. The hypotenuse is 25. One leg is 10. Try to find the length of the other leg. So I'm going to let that be x. Again, we know a squared plus b squared equals c squared. So on this one, 25 has got to equal c squared. So it's going to be 10 squared plus x squared equals 25 squared. So we got 100 plus x squared equaling 625. We're going to subtract 100 from both sides, and we get x squared equaling 525. Take square root of both sides, so x equals the square root of 525. Now we need to find the perfect square that goes into 525. Hopefully everybody would agree that 25 goes in to 525 21 times. So you got square root of 25 times the square root of 21. 5 times the square root of 21 is going to be the length of the other leg of the third side of the triangle. It also asks us, does this form a Pythagorean triple? Well, it does not, because 5 times the square root of 21 is not a whole number, and all three sides of the triangle need to be whole numbers for it to be a Pythagorean triple. Example 2, again, ask us to find the length of one leg when we're given the length of the hypotenuse and the length of the other leg. Please pause the video while you try to figure out example 2 without looking in your book. Okay, again, we know a squared plus b squared equals c squared. So for this one, we're going to say x squared plus 8 squared has got to equal 20 squared. X squared plus 64 has to equal 400. Subtract 64 from both sides, and we get x squared equaling 336. Take square root of both sides, and we get x to equal the square root of 336. Now we got to try to find any perfect squares that go into 336. Well, 4 goes into 36, so 4 is going to go into 336. But if you see a bigger perfect square that goes into 336, it's going to make it even easier. On this one, 16 goes in there 21 times, so x is going to equal the square root of 16 times the square root of 21. So our third side of the triangle is going to be 4 times the square root of 21, which is your answer to example 2. Quick check number 2, again, gives us the length of the hypotenuse and the length of one leg and asks us to find the length of the other leg. So again, I'm going to draw a triangle. A right triangle. Remember, Pythagorean theorem only works for right triangles. Length of one leg is 6, length of hypotenuse is 12. Find the length of the other leg. So please pause the video while you try to figure out x. Okay, a squared plus b squared equals c squared. So x squared plus 6 squared has got to equal 12 squared. So x squared plus 36 got to equal 144. So subtract 36 from both sides, and we get x squared equaling 108. Take square root of both sides. X equals, again, 4 goes in there, but if you see a bigger perfect square goes in there, it's going to be even easier. And 36 goes in there 3 times, so it's the square root of 36 times the square root of 3. So your final answer is simply going to be 6 times the square root of 3 is the third side of this triangle. Now let's look at example 3 that we talked about back at the beginning of the lesson. It says a Parks Department rents paddle boats at docks near each entrance to the park. To the nearest meter, how far is it to paddle from one dock to the other? Well, you can see they formed a giant right triangle where one leg is 250 meters and the other leg is 350 meters, and ask us to figure out how far it is on the hypotenuse. So for this one, hopefully you're going to, well, please pause the video while you try to figure it out. And then we'll see if you got it right, again without looking in your book. Okay, we've got, on this one you're going to have 250 squared plus 350 squared equaling c squared. C, again, is the length between the two docks. So you square 250 and you get 62,500. Then you square 350 and you get 122,500. That's got to equal c squared. Then you're going to add those two up and you get 185,000 equals c squared. Take square root of both sides and you get c to be approximately equal to 430 meters. On this one it said to the nearest meter, and since it's 430.1, your answer is going to be 430 meters. All right, now let's look at quick check number 3, which asks, when you want to know how far you have to paddle a boat, why is an approximate answer more useful than an answer in simplest radical form? Hopefully you would agree, if you just left that answer in simplest radical form, you still wouldn't know how far it is between the two docks. An approximate answer on this problem is much more useful. If you said, well, it's 81 times the square root of 13 meters, no one would really know how far that is. But when we say 430 meters, well, we know it's a little bit further than once around the track out there. Okay, now I want you to tell me the converse to the Pythagorean theorem. Again, if the Pythagorean theorem states, if you have a right triangle, then a squared plus b squared equals c squared. So what's the converse to the Pythagorean theorem going to state? Hopefully you would say, well, then if a squared plus b squared equals c squared, then you must have a right triangle. So now, what do you think they're going to do? They're going to give us problems, give us the length of the 3 sides, and say, is this a right triangle or not? Okay, example 4 gives us a triangle that has legs of 13 and 84, and a hypotenuse of 85, and says, is this a right triangle? Well, how are we going to do it? We're going to do a squared plus b squared, and see if that equals c squared. And if it does, this must be a right triangle. So, we're going to have 13 squared plus 84 squared, and see if that equals, so we'll put a question mark above that for right now, see if that equals 85 squared. Since 13 squared is 169 and 84 squared is 7,056 and 85 squared is 77,225, then we add those up and we see yes, that does equal, therefore this must be a right triangle. Okay, quick check number 4 says 3 sides of a triangle are 16, 48, and 50. Is this a right triangle? Please pause the video while you try to figure this out. Well, once again, we're going to try to see if a squared plus b squared equals c squared. So I'm going to put a question mark above it because we don't know if it equals yet. That's what we're trying to figure out. If a squared plus b squared equals c squared, then it is a right triangle. If it doesn't equal, it's not a right triangle. So we're going to substitute in the values, 16 squared plus 48 squared, and see if that equals 50 squared. Well, 16 squared is 256 plus 48 squared is 2,304, and 50 squared is going to be 2,500. Since that adds up to 2,560, that does not equal 2,500, so this is not a right triangle. Next, I hope you would figure out, well, next thing they're going to ask us, if it's not a right triangle, what kind of triangle is it? Is it going to be an obtuse triangle or an acute triangle? And as you can see in the next 2 theorems, it tells us if c squared is bigger than a squared plus b squared, it must form an obtuse triangle. If c squared is smaller than a squared plus b squared, it has to be an acute triangle. Alright, example number 5 asks us, if a triangle has sides of length 6, 11, and 14, is it acute, obtuse, or a right triangle? So, please pause the video while you try to figure this out. Well, the first thing we're going to do, once again, is 6 squared plus 11 squared, and see if that's greater than, less than, or equal to, so I'll put a question mark above it, 14 squared. 6 squared, 36. 11 squared, 121. And then 14 squared is 196. So we add those 2 up, we get 157. 157 is less than 196. So c squared is bigger. So this is going to give us an obtuse triangle. When c squared is bigger than a squared plus b squared, we have an obtuse triangle. Last quick check number 5, excuse me, gives us sides of length 7, 8, and 9. And ask us what kind of triangle is this? Is this obtuse, acute, or right triangle? So please pause the video while you try to figure this out. Okay, once again, we are going to say 7 squared plus 8 squared, and see if that's, this time I'll put a circle there for greater than, less than, or equal to 9 squared. 7 squared, 49, plus 8 squared, 64. Is that greater than, less than, or equal to 81? Well, you get 113, which is, of course, greater than 81. So c squared is smaller, so this must be an acute triangle. So this concludes lesson 8.1.